going to go into graphing linear relations, and the key thing is we're going over linear types of relationships, okay? And so we're going to graph them, and then from a graph, we're going to build this. This is the basis for a linear relationship. They'll sometimes call it like a parent function or a theoretical model. They have different names for this. But what's important here is the two things we really need to solve in order to create this equation are M and B, okay? First of all, we need to know what they stand for. Do you know what M happens to stand for?
No.
No? Okay, it stands for the slope of the line, okay? And there's a couple ways you can find slope. Slope is known as usually the rise over the run. Do you recall that?
Yeah.
And do you know how to find the rise over the run when you have 2 points?
Yeah.
There's a little formula. Y2, you ever heard this? Subtract Y1. Oh, you haven't seen
yeah.
Yeah? Okay. Y2 subtract Y1 divided
X1. X2 minus X1.
Okay, so look at all these equal signs. Slope. So M is equal to the slope, which is equal to the rise divided by the run, which is equal to the change in the rise divided by the change in the run. All these things are equal. Okay, so they should hopefully try to help you find the slope. While B is just the y-intercept. Okay, and what that is if we have, say we have a line here, we have our graph, the y-intercept of some line is exactly where it crosses the y-axis. Okay, that's what we're talking about, this specific point. That's considered the y-intercept. Okay, so with that being said, let's say I have a question here, and it is known as y is equal to 3x plus 2. Okay, I have to be able to define what my y and my b are. So I'm going to draw my theoretical model, my theory model. My theory model, I'll put it on top so I can try to draw a relationship between it. Y equals mx plus b. So we got to have to memorize that. Okay? And recall that we said, what colors did I use? Yellow. Yeah, yellow's not great, but m is our 3 in this case, and b would be 2. Okay? So we keep, did I use blue? Oh, I used green. B would be 2. So we'll kind of highlight them. So we know that our slope from this question is 3, and the y-intercept is 2. So let's get a graph out here. I've got a couple ready-made ones. Scale of 1. Perfect graph. Okay, bring this down. Okay, so here's what we know. Always start with a point on the line. So we know our y-intercept is 2. So if this is our y-axis and this is our x-axis, we follow the y-axis to the value of 2. Okay? The actual coordinate of a y-intercept, the x value is always 0 there. Okay? And the y value is 2. So on x, we're actually at 0, but the y value is 2 for this specific line. From that point, we have to graph the rest of this. So we do the rise over the run. The slope is 3, okay? But I want to relate it to a fraction. And the reason I want to do that is because it's usually easiest if we relate things to rise over run, and that over is essentially supposed to be like a division sign. It's a fraction. So if I have to relate 3 to rise over run, how do I make 3 a fraction? I can put it over some number and it won't change anything. Do you know what number that is? 1, that's right. So what it's saying is rise having to deal with up and down, we go up 3, and run, we go over 1. Now both of these values are positive. That's really important, right? Because in our graph, when we're going up,
it's going to the right,
is positive, that's right, and down is negative. To the right is positive, and to the left is negative, okay? So from this point, we go up 1, 2, 3, and we go to the right 1. So the next point is right here. Okay. Then we can go up again, 1, 2, 3, and over 1. And we have at least 3 points. We only really need 2 to draw a line. Okay? And we can continue it. Okay? Now I'm going to draw a similarity between these relationship here. So it looks like this guy's working out great. Goes like that, and we can kind of extend it here. Okay, top extension isn't perfect, but all these points are falling on this line, right? We notice we went down 1, 2, 3 over 1, or we went up 1, 2, 3 over 1. It was the exact same thing. Now, our slope was a positive value. Oops, sorry about that. Let's turn that off. So our slope was a positive value. So because it's a positive number, do you remember your rules with multiplying and dividing it all?
Yeah.
When we divide a positive divided by a positive, we get a
Positive.
Okay. There's also two other numbers we can divide and still get a positive. Two other operations. You know what they are?
Multiplication.
They're actually both negative. So our rise over run can also be -3 divide -1. So that seems odd. But if we divide -3 divided by -1, we'll still get 3. And if you notice on our line, if we go from the y-intercept or any point, let's go down 3. If we go down 3, 1, 2, 3, and over 1, I drew the graph a little off. But that's right on that point. I can do the exact same thing the other way. I can go down 1, 2, 3, and over 1. And it always falls on that same line. Okay? So just keep that in mind. We can go up or we can go down in order to do this. Now, let's do one other graph that might be a little more difficult. And the reason I want to show you that negative thing is because let's say I have part 2. Part 2 is y is equal to negative 2 over 3 minus 1. Okay, and there should be an x here. Okay, which is our slope in this question? What value?
This new one?
Yeah, this new one.
The what?
This new one. So what would be the slope? What would be the m?
2 over 3.
Yeah, so the negative.
Oh, negative 2.
Yeah, negative 2. And what would be the y-intercept?
The 1. Negative 1.
Negative 1. Good. So we'll start off with this one in red. We have to start at negative 1. Negative 1 happens to be here. Okay, so we'll focus on the red. Now the rise over the run is negative 2 over 3. Rise over run. Or is it 2 over negative 3? Are we able to tell looking at this? Seems confusing, right? Let's try both. Rise over run. So first one says to go down 2 to the right 3. We'll make that positive, right? So we go down 2, 1, 2, and we go to the right 3, 1, 2, 3. Okay. Let's do that again. Down 2, 1, 2, to the right 3, 1, 2, 3. Okay. Looks like that's going to fall into a line, right? Let's do the other one. The other one says to go up 2 and to the left 3. Up 1, 2, 1, 2, 3. Does that look like it's falling on the same line?
Mm-hmm.
It is. We go up 2, 1 more, and then to left 3. And we're falling on the exact same line. So it doesn't matter where I put that negative. And that's why I wanted to show you the double negative over here. It doesn't matter where we put it. We're still going to fall on this exact same line. Okay? And I know that's not perfect. Let me fix it a little because of where I started. But we end up on the exact same line where we put the positive and the negative. So this one is essentially how to graph the relationships. Okay? So we've learned how to graph them from an equation.